G'day trendsetters. Today I'm coming to you from Allied Cycle Works headquarters here in Rogers, Arkansas, which is right next door to Bentonville, Arkansas. Let's go inside and see what we can find and kick off a factory tour. Morning.
Hey, my name is Will Stoffel. I'm with Allied Cycle Works, and just want to tell you a little bit about ourselves, about how we got started, where we are, where we've come from. We've been around since about 2017. It was kind of a by happenstance sort of evolution, but our original founder, he wanted to bring back some sort of bicycle manufacturing to the United States. Obviously, that's not the cheapest thing to do, so he was trying to find out how to do it on a budget. Around that time, there was a company in the industry. They were named Guru. They were going bankrupt at the time. They were auctioning out their manufacturing assets, and our original founder went up to Montreal, Quebec, bid, hoping to win a press or one little other piece to kind of help the factory get going, and he ended up actually winning the whole lot. That was accelerated a little bit by the state of Arkansas. They essentially kind of subsidized for the move of the factory from Montreal down to Little Rock, Arkansas, and that's kind of how Allied got a quick and fast start. On the outset, when we were just getting started, we kind of had to do two things. We had to make sure that we could train our manufacturing staff to lay up carbon, and we also had to make sure that we could produce our own product and design our own product. And so those two things were kind of happening together. And we have a brilliant product designer and engineer. His name is Sam Pickman, came from Specialized. And he was in the background kind of developing our organic product, the Alpha, our first kind of road bikes. And then we were teaching our manufacturing staff how to lay up using one of the existing Guru molds that we had acquired from the manufacturing acquisition. And so that was great. You know, some people do know that the first bike that we developed, it was called the Founder. The Founder was, I think we made 100 of them, maybe 150, but that was really just the teaching and the process of laying up carbon, and that was a Guru mold. During that time, the tooling and the molds for what is now known as the Alpha family were being made. And so when we retired the Founder project, then it was all Alpha and all road and Alpha disc, and that's our organic product. And so that's kind of how we got a quick start onto our own organic product.
So Will, tell us a little bit about that lovely bike right there.
So this is the Able. Able's about 1.5 years old. It got its debut in Dirty Kansas in 2019, and it was a pretty great day. We launched it. We won both the men's and the women's overall in DK, so it was a pretty fantastic introduction, but this is kind of our dedicated gravel bike. We wanted to increase the tire clearance. We wanted to make sure that it handled a lot more confident on the gravel, so it's a good blend of geometries between kind of what we had with the all-road and then introducing its own spin on it, and this is what the Able is. Well, let's go see how a bike's made. So the first kind of step along the process is in the layup room. The layup room is pretty self-explanatory. It's where we take the carbon, we cut it, and we lay it up before it gets cooked, essentially. So where I like to start is kind of back here on the cutting table, and this is where we take carbon as you know it and start to cut it into little pieces. So depending on the bike, depending on the model, you know, there can be 3 to 4 different materials and different types of carbon that are actually used. We get carbon delivered to us and it's called pre-preg, so it's already injected and extruded using the resins necessary to make it the way that we want it. And it is unidirectional. As you can see, the fibers are running in one direction. This is our cutting table. This cutting table takes this carbon. There's a little blade on the machine over there. It talks directly with the computer behind us. And the neat thing is you can really kind of see all of the kind of Tetris work that goes into making sure we eliminate scrap and we make sure the pieces are cut the way they need to. But this computer, if you want to come over here, and you can kind of see all these different colors and all these different shapes, and this is a cut file. Each tube is a file. Each part of a bike that we have to bond together is a file. And right now, this is labeled as FK, that's a fork. We designate our models by numbers. 0, 1 is a, Alpha, 2, 3, and then 4 is Enable. So they're making Enable fork right now, okay? All of these pieces make up a fork. The two areas of the bike that have the most pieces of carbon will be a fork and it will be a bottom bracket. For obvious reasons, you know, there's a lot of stress put on those areas. A lot of stiffness needs to be had over there. Lots of surface, lots of bearings, so that's kind of a pretty important piece. So what they're doing is they're making sure the carbon is secure, they tape it down. There is a vacuum kind of underneath the table that will also help in keeping that carbon set, but this table now will start its work, and there is a little Sharpie marker attached and it's held right there, and it will start to put numbers on all of the little pieces that it actually will cut. Those numbers are important because those numbers are going to be stacked together in what we call the kitting process before they get delivered to one of these layup tables, okay? So this is kind of neat. We're going to see it kind of working right now. So that's the blade. It's cutting it. And this software in this table, it's meant to do two things. Obviously, it's meant to make sure that we eliminate a lot of scrap, and so all the pieces are kind of crammed together as much as they can. And it also is meant to make sure that each one of these pieces is cut at the angle, at the bias, at whatever longitude and latitude that it needs to in order to make the layup the way that our engineers and designers want the layup to be. So, you know, carbon, it's unidirectional, and it's a pretty, it's not brittle, but it's a pretty easy material to manipulate, and it's also an easy material to tear, right? If you go along the fibers, this is what you do to carbon. This is pretty amazing because the bikes that you ride, as strong as they are, start with this. But the actual act of taking these pieces and kitting them together, which kind of goes in some sort of sequential order, okay? They all kind of have numbers and letters, and they all kind of get kitted together. As you start the layering process on these layup tables, that's when the attitude of the bike kind of starts to manifest itself. So as you start taking these little pieces and putting them the way that they need to into the mold, that's when compliance becomes compliance, stiffness becomes stiffness, and all that sort of stuff. And so what they're doing now is they're kind of taking advantage of the saw being a little bit further away, and they're taking these pieces and now they're going to take them off and they will kit them together. All right. Once they kit them together, kind of the first quality step to ensure that we have all of the pieces is going to be right here in this little scale, and we are going to weigh each kit. And that is obviously important because we want to know plus or minus if we have the appropriate grams for the kit, so we know if we have an extra piece, if we're missing a piece, and we can kind of do our first QC check right there. Okay. So once they're kitted together, then they travel to any one of these 6 layup tables that we see here. Now, the cool thing is they're not all doing the same thing. That's by design. You know, we have to keep the table busy, we have to keep the molds free, and so forks are happening, chain stays are happening, bottom brackets are happening, seat stays are happening. It's all kind of happening together, and that's good because then the molds will get used, they'll get cooked, we can make more complete bikes faster, and so it's kind of a fun little strategy session of planning that all these guys do in here. So there are a lot of different ways that all these different molds happen. There's a large element of free-forming, there's a large element of using pre-molds, you know, but at the heart of it, you know, we want to make sure that all this carbon gets inserted into these hard toolings, and there is going to be maximum compaction of all the layers, because what you don't want in a carbon bike, you don't want any voids between the layers of carbon. You know, depending on the area of the bike, you can have 16 layers of carbon, you can have 5 layers of carbon. It really varies, but at the end of the day, we want to make sure that each of those layers find their way into the mold by the use of air pressure, temperature, and physical pressure, okay? And air pressure is important, and it starts with these baggies. You know, this is kind of a common thing with carbon molding. These baggies are going to use air pressure, which we will see here in a minute, and it will be injected into here when it's in the hard tool, and that's going to help kind of compress all of those layers together, okay? So you can see that this is a fork, kind of waiting to get loaded into the tool. So this is kind of the final tooling, right? So obviously right there, we're kind of loading a main triangle. The outermost layer is what's placed, and then all of the other kind of preforms are placed inside of it. And the other half of the tool is then closed on top, The plastic bags will be sticking out of the tool. They are attached to these. These obviously are little air intakes and injectors, and they will get hooked up to the presses that I will show you here in a little bit. And once it's loaded, it gets put on the little conveyor belt we have. It gets zipped outside. Okay, so these are going to be chainstays for enabled. This tool will hold 4 or 6 chainstays? 1, 2,
3 pairs.
3 pairs.
Yeah.
Okay, 3 pairs of chainstays. Trying to, maximize our efficiency of molding. But, once they're loaded, same process. They're going to get hooked up with the air. The bags are going to get sealed, and then they get zipped out. All right, so once the tools are loaded, the tools come out here to where the carbon presses are. We have 3 presses. The presses kind of use a trifecta recipe of physical pressure, 25 tons of it, air pressure, 125 psi of it, and temperature, about 230 degrees Fahrenheit of it. And that will essentially cook, as we call it, for about an hour, and then the pressure will blow off. The tool is ready to come off of the press, and it comes over here to this table. And one of our operators, Will, he's kind of the best at it. He takes the tool off. He scrapes off the excess flashing if it's there. We extract the plastic baggies from the tubes because that obviously is not wanted in the bike when you're routing hydraulic lines and cables and things like that. And then once it's out, he'll clean the tool. He'll put some material on there to essentially clean it, and then we send it back into the layup room so it can be used again and again and again and again. Okay? So when pieces of the bike come out of the tool, they get collected in these bins, and this is kind of cool because this is where the personality of the bike starts to happen. So this gentleman, Steven, he's getting a size small able, and right now he's got a bike that's in a whole bunch of little tiny pieces waiting in a blue bin in order to get bonded up. And so, it's kind of fun to take pictures, send it to the people, and they get excited about it, but this is start to where the bike starts to become the bike, all right? So these guys will wait here patiently. And this is kind of what a main triangle looks like when it comes off the mold. You can see that, it's really exact how we want the mold to be. We have the tapered step joint for the bonds, and this is how everything's going to get put together. All right, so now we got a bunch of pieces. Next thing we got to do is to make sure that they're true and aligned and bonded securely, and that's what the next step is. Okay, so what's next is we have to make sure that all the pieces in the blue bin get put together and make them, look like a bike, right? That's a pretty important thing. And so the next several steps of the process happen here. This is kind of frame prep and bonding. And so water bottle bosses, they get drilled here. If the bike has a front derailleur hanger, the front derailleur hanger gets drilled and applied here. The holes for the hydraulic lines, they get drilled here, okay? And the bottom bracket sleeve, we use a threaded bottom bracket. That sleeve has to be bonded in here. And all of that stuff happens before the frame then gets bonded together, okay? So this is a front derailleur prep, making sure that's all finalized. You can see the extra material that we kind of put there to make sure that guy's going to stay and stick around for the life of the bike. All the hydro lines, they're drilled, cable routing is drilled, holes on the down tube drilled. That kind of all happens in this prep area, right? But before all of that happens, it does need to get bonded together. These are the jigs that we use to do so. The first thing that generally goes in is the bottom bracket sleeve. We use a lot of epoxy. That bottom bracket sleeve gets inserted in, and then it cures. Once it cures, then here, I'll grab you a little example here. Once that bottom bracket sleeve cures, then we'll put the main triangle up here on this jig. This bottom bracket part of the bike will live here, and then we'll epoxy the seat stays, we'll epoxy the chain stays, and then it sits here on this jig and cures. Once it cures, it's aligned, it's sound, it's true. If you wanted to put a crank on here, handlebars, wheels, you can ride this bike. Like structurally, this bike is ready to go. There is really only one remaining step that we do to ensure the structural integrity of the bike, but it's also a cosmetic piece. Everywhere you have a bond joint, we want to make sure that bond joint is covered so it will never propagate itself into a paint crack. Even though those things aren't structural by any means, they're kind of ugly when it happens, and so there's a really clever way that we get around it, and that's called overwrap. So that takes a quick trip back into the layup room, and I'll show you how that happens, but that's how we cover up these bond lines. Once it comes off the jig, the name of the game is to really just take the areas where there is a bond line and cover it up. It's a pretty straightforward process. It does take a little bit of time, but essentially we'll take these long strips of carbon, we will apply them to the frame, then we put some vacuum seal tape on top of it, we throw it in the oven again, and that basically covers up that bond line area. And so now the name of the game is just to make sure that it's prepared in the correct way so it will look good when it accepts paint. Okay, so this is overwrap. Depending on the bike, there's going to be different areas where we're bonding it, but that's kind of the last structural piece of the puzzle. After the bikes come out of the oven with overwrap, structurally they're a bike. They are the way that we want them. They will ride like a bike, and so the name of the game is frame prep and sanding, and this is a very labor-intensive part of the process, but we have to make sure that the surface is completely immaculate before it accepts paint. Otherwise, it's going to look funny. And so it's a lot of back and forth of primer and sanding, but this is probably the step that does require the most time, and one of the steps that we have tried to really make headway in chopping a lot of time off the overall length of time it takes to make a bike. And so the sanding booth is over here. Kind of get an idea of what we're doing, right? So the raw bikes will come in, they will get prepped. We do put primer on these bikes, and we sand that primer into the frame because carbon obviously is, if you just take a look at the raw look of it, if you put a magnifying glass on it, there's a lot of eddies, there's a lot of voids. All those voids need to get filled in, they need to get sanded smooth, especially the areas where there's bond joints, as you saw in the overwrap step. We need to make sure that they're the same height and shape and surface texture as the rest of the bike, and that's what they're doing here. This, as you can see, is 100% manual. There's no automation of this step at all. It's all wet sanding, hand sanding. That's the name of the game here. But the gray stuff you see, that is our primer. Primer gets applied to the bike, and then primer gets sanded in. It does a really good job of filling in a lot of those voids and eddies. And it'll take a trip to the priming booth, a couple of times before we put our final sealer on there, and then that is what is kind of the last piece of the puzzle before it goes to paint. So once the sanding process is done, that can take hopefully around 3 to 5 hours. We're always trying to chop time off, but once that's done, sealer gets put on the bike, then the bike is ready to go to paint. The paint booth that we have, this is kind of the newest addition. When we moved our factory up to Northwest Arkansas from Little Rock, we did not bring the paint booth. We bought a new paint booth. It's really nice. We pride ourselves on making very aesthetically pleasing bikes, and paint is the one thing that we need to make sure that gets executed, and so we have a brand new paint booth. And it's kind of fun. It's the brightest room in the building, but this is it. We can do our mixing here. We can give you a quick entrance. So you're standing on this is where everything goes. It's a downdraft booth, right? So it allows us to paint all these bikes and have no cross-contamination. We can cure them here after they get applied with clear. But the way that we generally do our bikes is we paint our logos on. And so the process of paint is the first color that's applied will be the logo color. And then once that dries, the frame comes out of the paint booth and they put the masks on for the logos. And then the bike comes back in here and it gets its body color applied, which you see here with this black bike. Once it goes out of the booth again, they'll take an X-Acto knife and they'll take those masks off, so you'll see the logos. And then it gets shot with clear or gloss or a matte clear, whatever it is, but this is what happens here. We do mix our own paint here. We use PPG automotive paints, and so we have a pretty cool computer. It generally goes by automotive codes, but it'll tell us the recipe bike leaves paint, you know, there is kind of one more final buffing and detailing step, and that all happens in our assembly room. This assembly room is also the place where we strap on parts and put it in a box, so come in here. So this is it. We got the Three Musketeers in here. This is kind of where the, no, I just made that up. You guys are good. Okay, so this is the buffing and the detailing, right? So if it's a gloss bike that comes out, Noel makes sure that, you know, it doesn't have any fish eyes and it looks as great as it can be. And then once it passes that step, then it goes on to these two assembly stands where we will then put parts on here, you know, make sure everything is updated. I mean, it's a pro build and assembly, and then we down build it and put it in a box.
People really need to see this paint finish in person because the camera does not do it justice.
I know, it's tough. And the renders do even worse justice that we have on our computer. I think one of the neatest things to really underscore the importance of U.S. manufacturing in the bike industry is the fact that we can take a model, a prototype, test it, and put it in production here, under the same roof. We don't have to worry about time delays, tooling delays, anything like that. We can all do it here. And so this little corner right here is where we do a lot of the testing. When we do develop new products, we first prove them on these testing machines, and we have a few of them here. They all do different things. You know, they range from fork strength tests to fork flexion tests to head tube deflection, pedal fatigue testing. It all happens here. And it's kind of fun, you know, once we're in the season of developing new products, these things do have bikes on them. You know, it's really kind of terrifying sometimes to see the rigors that a prototype frame goes through to prove it here before we put it into the production floor. But we have all of this capacity and ability in-house to do it. And I do truly think that this is one of the really fundamental aspects of making U.S. bike manufacturing stand out, is that we get to do it all here, and we can do it quickly. Is pretty much the end of the tour, you know, from beginning to end. That's really all that happens here in the factory. So I appreciate you guys coming. Appreciate Jason from Cyclist coming. That's it. That's how we make bikes.